Hello everyone, welcome to these training videos. The course here is AI Space Exploration and it consists of 4 parts: a course overview, an introduction to the uGot hardware components, an introduction to the matching applications, and a demonstration class. First of all, we will cover the basic information about the course, with space exploration as the background. This course integrates science and technology in different scenarios, creating virtual scenarios such as flying plane, lunar exploration, cave mystery, and Mars base. This course encourages students to use uGot's multifunctional forms and Open Python programming languages and apply AI technologies, including intelligent speech, machine vision, human-computer interaction, and natural language processing to solve different problems through immersive tasks. Students will use the uGot kit to build models, understand and learn the structure and functional features of uGot, and realize applications of uGot in various scenarios through Python programming. This will help students understand aerospace, robotics, AI, and other cutting-edge technology applications. It will also cultivate their AI literacy, scientific inquiry, and innovation ability. This course is recommended for students in years 7 and 8. There are 30 lessons and each one lasts 40 minutes. We have also incorporated the AI Space Exploration Kit and a prompts kit to enrich the classroom teaching. The programming software used is uPython code. It is designed according to international standards and guidelines such as AI4 K12 and CSTA. It helps students better understand the scientific processes, methods, concepts, and principles, enabling them to cultivate a better attitude towards science and life. These 30 lessons meet the learning needs of students for 1 academic year and are divided into 4 units, with 13 general topics and 1 activity topic. The course material is also graded according to the level of difficulty. Unit 1 is titled Flying Plane. The uGot form used is the transforming car. It has 3 topics: uGot's preliminary exploration, uGot movement, and getting ready. uGot's preliminary exploration allows students to experience and learn how to build a uGot transforming car and implement its functions to interact through the screen with uPython programming. uGot movement requires a uGot transforming car to move materials, and students will use motion control functions to achieve the forward and backward movements and left and right turns of the vehicle. Getting ready will teach students about input statements, variables, and conditional judgment. They will also use programming to learn how to identify functions like the uGot main controller light display, TTS voice broadcasting, and motor rotation. Unit 2 is titled Lunar Exploration, and in this unit, we will use the wheeled electrobot. It has 3 topics: avoid, turn, flap and move, lunar crater patrol, and smooth return. Avoid, turn, flap, and move requires uGot to use its built-in gyroscope to climb over craters and travel along an L-shaped path. Lunar crater patrol requires uGot to thoroughly observe a target lunar rock. The students will use the for loop to make uGot move 1 cycle around the target. Smooth return leads the students to understand the basic principles of color recognition and localization. They need to program uGot to avoid obstacles and reach the target base. Unit 3 is titled Cave Mystery, in which we will use the spider robot, and it consists of 3 topics: rugged cave, meandering forward, and far-sighted observation. Rugged cave requires students to change the uGot wheeled and legged robot into the spider robot and program it to avoid obstacles. In the topic meandering forward, students need to implement the spider robot's vision patrol function. It needs to crawl autonomously inside the lava cave. Far-sighted observation requires uGot to use the vision recognition function to scan the images of the cave and identify the composition of the lava cave. Unit 4 is titled Mars Base, and in this unit, the uGot quadruped robot is used. It consists of 4 topics: intelligent people recognition, human-computer communication, following like a shadow, and Mars party. In intelligent people recognition, students need to change the spider robot into the quadruped robot and use the facial recognition function to make it recognize faces and people's emotional states. Human-computer communication guides the students to realize uGot's voice recognition function, sound source localization function, and voice broadcasting function through intelligent speech technology. In following like a shadow, students will implement the localization and tracking function of the April tag code through vision recognition and programming control. In Mars Party, students need to program uGot to implement the dancing function and enable uGot to adjust its own actions through human posture recognition. Finally, there's an activity class, Smooth Return. In this activity class, students need to assemble suitable uGot robot forms based on the terrain features. Then they will use April tag localization to locate and obtain the necessary parts for fixing the spacecraft. Lastly, they will use the robotic arm to replace the parts and guarantee a secure return of the researchers to Earth. This course has many resources that teachers can use. The AI Smart Education platform integrates relevant course materials. It offers electronic course packages such as PowerPoint lesson slides, teachers' books, and demo programs. Students can also use electronic evaluation books and textbooks in class. The AI Training Center is provided for AI knowledge learning and assessment. It has the latest version of uGot programming software and the AI micro certifications for learning evaluation, making it easier for teachers to teach. The uGot software also provides 3D dynamic building graphics of the uGot robot. They can be used in different courses to help teachers plan and simplify the teaching tasks. Teachers can use them as needed. Next, we will learn about the hardware equipment used in this course. Let's start with a video and learn about uGot's forms and functions.
Meet uGot, a versatile AI robotic kit. Featuring a unique modular design, and it's easy to assemble. You can build the quadruped robot in 2 minutes. Awaken it with just one click on the app, and it's capable of 360 degrees far-field audio recognition. By replacing a few parts, you can transform it into an engineered vehicle. Pick up a bone easily and play with your dog with uGot. Here comes the wheeled and legged robot you have never seen before. It can perfectly balance while go over the uneven terrains. You can also experience the FPV mode with the uGot app. With face recognition, uGot knows you and who to play with. Invite your loved ones to explore with uGot. From Python to graphical programming, both adults and children can interact with. AI gesture recognition. Need more fun? No problem. Here's the transforming car. It is capable to go over obstacles, drive over gravel, climbing mountains and crossing puddles. More combination and more fun. Explore the future of robotic with uGot.
From this, we can see that the multi-mimic robot uGot uses a new knob lock design. This allows for easy disassembly and reassembly to switch between 10 different forms. We will mainly use the 4 forms of transforming car, wheeled and legged robot, spider robot, and quadruped robot in this course. The uGot controller is a convenient, flexible, and handy open-source hardware component. It is compatible not only with Python programming, but also with uGot graphical programming software. It has a built-in microphone array, strip lights, a speaker, a Wi-Fi module, a Bluetooth module, and a 9-axis gyroscope. Its 2.4-inch LCD touch display also makes controlling and using uGot much easier. The controller has many extra ports, such as customized Type-C interfaces for connecting motors, servos, sensors, and other electronic components. USB 2.0 and 3.0 interfaces for cameras, and open-source interfaces for open-source sensors, Raspberry Pi, and other devices. It helps students to access and understand open-source devices. The battery can be powered by magnetic attachment. The uGot controller has 6 Type-C interfaces that can connect to different electronic components and assign ID numbers to connected devices automatically. The built-in 2.4-inch touchscreen clearly displays system information and program running status. The uGot main controller can store multiple sets of programs at the same time. These programs can be selected to run when needed, making it easier for students to use. The controller with an independent NPU can provide offline version computing power, gesture recognition, human posture recognition, text recognition, key face point acquisition, image recognition, deep machine learning, and automatic driving. The kit contains a lot of equipment parts, mainly high RPM motors, high torque servos, and related connectors, as well as bionic parts such as wheeled feet, point feet, and arc feet, making it easy for students to build various robot forms. Now, we will use the uGot transforming car to show you the building process of the uGot robot.
Let's prepare all the necessary materials and drawings. First, take out the 4 servos and calibrate them. Take out the expansion box and install the servos and connectors. Then, install the bottom cover, thumb screws, and wheel arms. Now, it's time to assemble the motor to the rubber wheel and install the assembled wheel. Pay attention to the protruding end of the battery. Then install the battery, the cable, and the main controller, and insert the cable into the port of the controller. Refer to the figure. Finally, install the cable at the bottom and plug the end into the port on the motor. Once completed, the bottom cover will look like the one in the figure, and the transforming car is all set.
Now that we have learned about uGot's hardware equipment, next we will explore its related applications. The AI Smart Education Platform is a desktop application that helps K-12 teachers and students with UB-Tech AI robotics courses. It differentiates between the teachers and the students with different accounts. It provides teachers and students with a teaching center, online access to course content, AI practical training operations, uPython programming tools, and 3D simulation model building tools for AI teaching and learning. Student and class management platforms, class cloud, and community creation sharing, teaching results assessment, and report output. The aim is to simplify the teach, practice, test, assess, and manage process, and make it easier for teachers. This lesson will be combined with the AI Training Center of the AI Intelligent Education Platform and enable the students to experience and learn AI knowledge such as facial recognition, image recognition, speech recognition, machine learning, and posture recognition. The practical experience will help students deepen their understanding of the principles of AI technology and enrich the teaching of the course. We can use the Python programming software for code programming for uGot. uPython is a text-based code programming tool designed for middle and high school students. It allows students to simplify and quickly achieve all kinds of interactive creations between software and hardware. By doing so, they can see the effect of their programming outside of the computer, which makes code learning more fun. The software includes commonly used libraries such as artificial intelligence and data processing, so that students can easily create interactive games. They can learn and understand the associated coding and programming logic more intuitive by enjoying games while learning. At the top of the uPython interface, you can find a menu bar. It enables you to manage and edit files, copy and cut cells, set up the Python editor, search and install Python libraries. In the middle, there's a toolbar for handling the codes, and in the lower part, there's a code editing area. Click the Run button to run the codes in the input area, and click the Clear button to clear the contents in the output area. Next, let's see how we can control the uGot robot through uPython code programming. Firstly, switch on uGot. Swipe left to enter the settings. Scroll down to find the system information. Click to view the local IP address. Next, import uGot functions. Create an object named got and use the got.initialize method to pass in the IP address you just viewed to establish a hardware connection. We can demonstrate the connection of uGot by making the main display show a color. Here, the display is controlled with a code that shows the background color, and we can set the color parameter 0 to 8 to show different colors. Run the codes, you can see that the display will show different colors for different values entered. Next, we will present the class Lunar Crater Patrol. Hello class! Today we're going to study topic 5 in Unit 2, Lunar Exploration of the course AI Space Exploration. This topic describes the primary task of lunar rock exploration. We will be using laser distance measurement and the repetition structure. First, let's start with the learning objectives of this lesson. We will learn about the principle of the laser distance measurement sensor and its control method. Then, study the use of the for loop and tell the differences between a for loop and a while loop. And finally, design a task, describe its implementation steps, and refine and enhance your program through reflection and communication. This lesson includes 4 parts. Let's see what problems uGot has encountered. uGot crossed the crater and entered the interior of the lunar crater, then proceeded towards the lunar rock coordinates provided by the satellite. It didn't take long for the target lunar rock to appear within uGot's sight, and uGot smoothly approached it to begin exploration. As there are no reference objects on the moon, uGot needs to measure the distance to the target lunar rock to determine its size. How can we know the distance between uGot and the lunar rock? And how can uGot complete the exploration task of moving one cycle around the lunar rock? First, we need to obtain the distance data and then program uGot to circle once around the target lunar rock. To accomplish these 2 tasks, what problems we need to solve? That's right. Let's first tackle the issue of how to obtain the distance data between uGot and the target lunar rock. Then, figure out how to program it to complete the exploration task. Let's begin by exploring how to obtain the distance data through a laser distance measurement sensor. As we all know, humans can estimate the approximate distance to our target by sight and determine the approximate location of a sound source by ear. Can machines do the same? Machines can detect and measure external information through sensors. There are many types of sensors, and they can measure different types of information such as temperature, light, distance, color, sound, and pressure. They are used in various fields such as consumer electronics, healthcare, environmental monitoring, and industrial automation. Sensors collect data for AI. Physical or chemical quantities measured by sensors can be used to train and optimize AI models. The quality, accuracy, and timeliness of sensor data have a significant impact on AI's performance and effectiveness. Have you ever seen these scenes in your life? What principles are used to implement the functions? That's right, reversing radar, echolocation, and infrared automatic doors all use distance detection to achieve corresponding functions. The first two use ultrasonic waves, while infrared doors use infrared rays. Sound waves, infrared rays, and lasers reflect upon contact with an object and propagate at a certain speed in the air. We can determine the distance to the target by measuring how long they take to travel. The moon's surface is a vacuum environment without an atmosphere, which creates extreme changes in temperature. Due to this, it is impracticable to use ultrasonic waves and infrared rays to measure distances on the moon. However, laser propagation is not affected, and we can use a laser to measure the distance on the moon's surface. uGot can measure how far the target object is using a laser measurement sensor that measures distances from 2 to 250 centimeters. First, the distance measurement sensor sends a laser beam which reaches the target object and then reflects. The sensor receives the reflected laser beam and records the time it took for beam to be sent and received. Finally, the sensor calculates the distance traveled by the laser to calculate the distance between the sensor and the target object. After learning about the principle of the laser distance measurement sensors, please complete Task 1. Program to obtain the distance information returned by the laser distance measurement sensor. First, we need to install a distance measurement sensor on the wheeled and legged robot. Begin by connecting one end of the Type-C cable to the sensor. Then fix the sensor into the connector in front of uGot. Finally, connect the other end of the cable to the main controller port. Do you know how to obtain the value of the distance measurement sensor? We can use the obtaining distance measurement sensor data method to read the data. This returns distance information in centimeters between the sensor and obstacle, with a value type of int. A return value of -1 indicates that distance information is not acquired. The ID in parentheses indicates the ID value of the sensor. How do we find out the ID value of the sensor? We can determine the sensor ID number by using the interface to combine the port number of the distance measurement sensor, which is attached to the main controller port, with the serial number of the serial distance measurement sensor. Now you can start programming. Begin by resetting the wheeled and legged robot through initialization. Start the robot and ensure its balance. Acquire distance data from the distance measurement sensor and print out the display. Run uGot and align the distance measurement sensor with the target lunar rock model to obtain distance information and complete the task. Congratulations! You have completed Task 1 and obtained the distance data between uGot and lunar rocks. We now understand how the laser distance measurement sensor works and have programmed commands to retrieve the distance data. What's coming up next? Now, let's try to figure out how we can program uGot to complete the exploration task of circling once around the target lunar rock. To better assess the overall condition of the lunar rock, uGot needs to take photos and explore the rock from various angles by moving one cycle around the lunar rock. To make it easier, we program it to move one cycle following a square route around the target lunar rock. How many steps are needed for uGot to complete one cycle around the target lunar rock using this square route? To enable uGot to do so, we can make uGot perform the forward turn command 4 times. Even though uGot is only moving around the lunar rock once using the simplest square route, the command flow is still complicated. How can we make uGot's commands simpler? Imagine that we want a robot assistant to make biscuits for a birthday party. How should we give the commands? That's right. First, blend together the ingredients to form the dough. Next, shape the dough into individual biscuits and then bake them. By giving the robot step-by-step commands, it can continue to make biscuits until there are enough. It is tedious to keep repeating commands to the robot. To lessen the number of commands and improve their structure, we can use a repetition structure instead of the recurring commands in the sequence structure. Simply tell the robot to repeat the commands for kneading dough, molding, and baking multiple times. Similarly, we can replace the sequence structure program that moves one cycle around the lunar rock with a repetition structure that repeats 4 times. This not only optimizes the program structure, but also reduces the amount of code. In Python code programming, the while loop we learned involves repeating the execution multiple times. When the judgment condition of the loop is true, the loop body is executed until the condition becomes false and the loop ends. There's also a for loop. It consists of for paired with in. This loop iterates over each element of an object in turn, passes the value of the element to a temporary variable, then executes the loop body once, and in this way achieves repetitive execution. A for loop can traverse any sequence object or iterable object, such as strings, lists, dictionaries, and collections. The specific use is shown in the figure. You can use I to represent the serial number of the element in the sequence, and after executing the loop, it goes to the next element and runs the loop body again until I traverses the end and breaks the loop. Both the for loop and the while loop enable loops, but they have their own characteristics. In terms of control, a while loop is controlled by judgment conditions, and a for loop is controlled by traversing the sequence. A while loop is ideal for situations where the number of loops is uncertain, and a for loop is better when the number of loops is known or when the sequence is traversed. Lastly, although a for loop is generally more concise when traversing a sequence, the while loop offers greater flexibility in terms of conditional judgment. Next, try to complete the demo program of outputting 0 to 4. You shall use the sequence structure, while loop and for loop, respectively. Here in the figure, we have 3 demo programs that accomplish outputting 0 to 4 using the sequence structure, while loop and for loop, respectively. Please edit and run the following programs separately and describe their features. The sequence structure uses print to print 0 to 4 one by one. The while loop uses I to indicate the number to print. Then the condition of I less than 5 is met. The loop starts from 0, prints I, and then adds 1, and so on, in order to print 4, and then adds 1 to get I equals to 5, which does not meet the conditions of I less than 5. And this time, the loop ends. Compared to the sequence structure, the code is much more streamlined, and the for loop statement is simpler and clearer. 0 to 4 can be directly output by using the range bracket function and printing I. Both while loops and for loops can perform repetitive actions and avoid the tediousness of sequence structures. The while loop structure is more intuitive and clearer, while the for loop structure is more concise. You may choose which one to use as needed. Next, try using a for loop to program uGot to move one cycle following a square route around the target lunar rock and light at the vertex of the route. Refer to the flowchart and learn about the program logic. When the number of execution is less than 4, uGot performs a loop of moving forwards, lighting at the apex, turning right, and ending the loop after forming a square route. Now you can start programming. Some of you may have already completed the programming. If not, refer to the demo program. The for loop statement implements the whole programming by first resetting the wheeled and legged robot, starting it up and keeping it balanced, and then completing the action of moving one cycle following a square root and lighting up. The for loop is used to iterate through the range bracket for function to iterate through the execution of the series of actions 4 times. If you have finished writing the code, run your program and control uGot to complete the task. Congratulations! You have completed both tasks. Now you can take on the extension task. For a more detailed exploration of the target lunar rock, we can observe it more comprehensively by making uGot's trajectory more towards a circle. By using the for loop statement, you can enable uGot to move around the target along a regular hexagonal trajectory and achieve the flow rotation effect of the main controller's LED light bars at the vertex of the hexagonal trajectory. Enable the LED light bars to light up and go out 3 times in sequence in each direction. The figure shows the route of the extension task. uGot performs the walk and turn command 6 times in a loop. The turning angle is 60 degrees, and it achieves the light effect of flow rotation by nesting the for loop at the vertex position. Now, you can start programming. Some of you may have already completed the programming. If not, refer to the demo program. The first level of the for loop allows uGot to perform forward movement, lighting and turning actions 6 times. The second allows it to complete the light effect of flow rotation 3 times. If you have finished writing the code, run your program and control uGot to complete the task. Finally, let's review this lesson. The lesson topic is Lunar Crater Patrol. We learned about the principles of laser distance measurement sensors, program to read the distance values, review the while loop, learned about the features and use of the for loop, and used it to enable uGot to complete the exploration task of circling once around the target lunar rock. Please showcase your creations from this lesson and share the features. You can introduce what you have created and identify areas to be optimized. What challenges did you face? How did you overcome them? What new knowledge did you gain from the course? uGot has successfully completed its exploration and acquisition mission. However, to return to the moon base, it still faces the challenges of avoiding obstacles along the way and recognizing the color makings of the base. Let's look forward to the next lesson.